Okay, so welcome back, and so today we're going to do our first example, and we're going to go back to the beginning when I asked the question about the function 1 over x. So we're going to answer one of those questions right now. So we take the function 1 over x over this interval. So I drew the picture of it, so this is what it looks like. It's the reciprocal function, so we've got this side and this side. And so we're only taking the interval from 1 to positive infinity. So we're going to find out, does this have a finite or infinite area? Okay, now if you look at the area, the amount that you're adding is getting smaller and smaller and smaller. Okay, so it does seem that it's going to converge to a single value. Okay, so let's see if we can confirm that. So the first thing we're going to do is set up the integral. Okay, so the way we're going to set this integral up is we're going to go from 1 to positive infinity of 1 over x dx. Okay, now then we're going to rewrite this again. We're going to use limits. So we're going to take the limit as t approaches positive infinity of the integral from 1 to t 1 over x dx. Okay, so now all I'm doing is applying the definition. So now I'm going to evaluate this. Okay, so before I evaluate it, I'm going to integrate, right? So now let's integrate this. So again, the limit as t approaches infinity gives me what? Well, the integral of this is going to be the natural log of the absolute value of x, right? So this is going to be and then we're going to evaluate that from 1 to t, right? Okay. So now let's keep going. So this is going to be the limit as t approaches positive infinity of, now here's where we're going to evaluate it at t and at 1. So this is going to be the natural log of the absolute value of t minus the natural log of the absolute value of 1 as such, right? Now, the thing is the natural log of 1 is just 0. Okay, so that goes away. Okay, so now what do we end up with? Well, in this case, we end up with the limit as t approaches positive infinity of the natural log of the absolute value of t. And since t is positive, we don't need the absolute values because we're going off to positive infinity. Now, what happens to the natural log of t as t goes off to positive infinity? Well, that's going to go off to positive infinity too. So the result is that our integral diverges to positive infinity. So the area is infinite, which might be surprising, but that's the truth. That's the fact. So this area, the area under this curve from 1 to positive infinity is actually infinite, even though the amount of area that you're adding is getting smaller and smaller and smaller. Okay, that's it. See you next time.